This is a postgraduate pediatric orthopedic video series. In this video, Professor Mohamed Kenawey, a consultant pediatric orthopedic surgeon, will take us through the frontal plane deformity analysis. And these are part of chapter 23 of the postgraduate pediatric orthopedic video series.
Map the ABC in the frontal plane. MAC deformity analysis. MAP stands for M equals measure the mechanical axis deviation, MAD. A equals analyze joint orientation angles. P, pick the deformed bone, source. ABC stands for A equals apex of the deformity, uni or multi-apical deformities. B equals bone cut, equals correction, acute or gradual. True normal limb alignment is defined as the collinearity of the centers of the hip, knee, and ankle joints. The mechanical axis of the lower limb in the frontal plane is defined as a straight line connecting the center of the femoral head to the center of the ankle. In most individuals with normal limb alignment, the mechanical axis passes slightly medial to the center of the knee. By drawing the mechanical axis of the limb, we can distinguish genuvarum and valgum deformities. In varus deformity, the mechanical axis passes medial to the knee joint, while in valgus deformity, the mechanical axis passes lateral to the knee joint. Regarding the mechanical axis of a single bone, such as the femur or tibia, it is the line connecting the center of the joint above to the center of the joint below. On the other hand, the anatomical axis is the mid-diaphyseal line of the bone. In the femur, the mechanical and anatomical axes form an angle called the AMA, which averages 7 degrees. In the tibia, the mechanical and anatomical axes are parallel. The next step is to draw the joint orientation lines. Femur, the proximal joint orientation line is drawn between the center of the femoral head and the top of the greater trochanter. The distal joint orientation line is drawn between the convex surfaces of the femoral condyles. Tibia, the proximal joint orientation line connects the concavities of the medial and lateral tibial plateau. The distal joint orientation line is drawn between the medial and lateral shoulders of the talar dome. When we draw the mechanical axes of the femur and tibia along with the joint orientation lines, a series of angles can be measured. Each angle is named based on the location, lateral or medial, whether it is proximal or distal, and the associated bone. Therefore, we have LPFA, lateral proximal femoral angle, LDFA, mechanical lateral distal femoral angle, MPTA, medial proximal tibial angle, LDTA, lateral distal tibial angle. One additional angle is the JLCA, joint line convergence angle, which is measured between the distal femoral joint orientation line and the proximal tibial joint orientation line. These lines should ideally be parallel or form a maximum angulation of 2 degrees. If we apply the same analysis to the anatomical axes, we obtain similar angles for the tibia because the mechanical and anatomical axes are parallel. On the femoral side, 2 additional angles can be measured: AMPFA, anatomic medial proximal femoral angle, ALDFA, anatomic lateral distal femoral angle. Average values and normal ranges are provided for comparison, illustrating the differences between the mechanical and anatomical axes and their orientation angles. MAC deformity analysis. MAP stands for M equals measure the mechanical axis deviation, MAD. A equals analyze joint orientation angles. P, pick the deformed bone, source. ABC stands for A equals apex of the deformity, uni or multi-apical deformities. B equals bone cut, equals correction, acute or gradual. MAP process. Begin by drawing the mechanical axes and measuring the MAD, which is the distance between the axis and the center of the knee joint. An additional M can be added for measuring the mechanical Tibiofemoral Angle, MTFA, which is the angle between the mechanical axis of the femur and that of the tibia. This angle represents the total varus or valgus deformity in the coronal plane around the knee. Analyze joint orientation angles. In a given X-ray, for example, bilateral genuvarum deformities with 12 degrees varus on the right and 19 degrees on the left can be observed. The right side varus deformity arises primarily from the distal femur and proximal tibia. The left side varus deformity is further compounded by an abnormal JLCA. In another example, a 20 degrees left side varus deformity is attributed mainly to an abnormal MLDFA.